outlined yesterday. I want to go over the homework, but I'm going to go over the homework with a twist. So I am asking for full participation. Since you didn't get me a gift, you can participate in my class today. And I'm just going to kind of go over the homework. It's going to be a little different, a little weird. So I want to start off with, we're going to just start with the first question, which is which graph best represents the relationship between the angle of insolation and the intensity of insolation. So before we get too far into this, I need to make sure you know what all those words mean. So let's first start with the angle of insolation. All of the x-axes are all the same. They start off at a 0 angle and go to a 90-degree angle. So what I would like you to do right now is point where the sun would be if it was at a 0-degree angle. Everyone, class participation is required today. It's my birthday. Show me, where is a 0-degree angle? Okay, it's straight out. Everybody with their arms straight out. It's my birthday. Put your arms straight out. Did you want me to do something for your birthday? Yeah. Did you tell me over and over again I wanted you to do something for my birthday? Because I am. Arm is straight out. That is a 0-degree angle. Now, guys, I just want to make sure you guys know what a protractor is. So yeah, it's one of those tools to remember. Use them in math class to find angles. They're marked off. Here would be a 0, 180, 90 degree would be there. You guys, and I think there's usually like a little, usually like a hole there, isn't there? Something like that. I don't know. But that's a protractor. That's what I'm talking about with the 0 degree. Now imagine this being the ground. There's that 0-degree angle. That's what I'm talking about when I keep talking about zeros. So straight out is making a 0-degree angle with the ground. Here, now everybody put your arm up at 90. See how your arm is making that 90-degree angle with the ground? That's what I'm talking about with 90. So 0 and 90 and everything in between are our choices. When I say low, I'm talking near the ground. Sun's low in the sky, 0 degrees, maybe a few degrees above the horizon. Low degree is near the ground. High is highest you can get is 90 and it's straight above your head. So that 90 degree is the sun and the ground. That's where I'm talking about with the 90 degrees. So here, when it's a 0-degree angle, I want you thinking ground. When it's a 90, straight up. So ground to straight above you. What's the intensity of insolation mean on the y-axis? What's intensity? What does it mean if someone's being a little intense? I don't know what you're talking about. Yeah, what? Okay, so being intense means they're being a little strong, being a little aggressive. Low intensity, I may not have been quite as intense yesterday. My shirt was really itching me and putting me in a really bad mood yesterday. But I'm over that. So now I put on comfy clothes today. So when they're less intense, that's a low, relaxed, not as strong. So let's talk about this. When the sun is on the ground or near the ground, is the sun very intense or less intense? When the sun is near the ground, it's a low intensity. When the sun is straight above you, beating down on you, what's the intensity when the sun is straight above you? More intense, very intense. Which one of these graphs says that? Everybody stop and think. I know I heard a couple of answers, but I want everybody to stop and think. Which graph says when it's at the ground, it's not intense, and when it's straight up, very intense? Show me with your fingers. How about that? Class participation is required today. It's my birthday. No, I got a little something in my find my cupcake I had earlier. Which one of these says it's when it's on the ground, low intensity? When it's straight up in the air, high intensity. Those of you participating got it right. That's answer 3. But I'm going to change this up a little bit. So imagine, I'm going to switch. Imagine if it said, instead of saying angle of insulation on the bottom, let's imagine it said latitude. So I keep the exact same graphs. I just changed, so everybody paying attention because you can't look at your papers because now it's only up here. So I guess you could imagine changing it on yours. But if I change the x-axis to latitude, basically just changed one thing about the graph. And I ask you which one is true for latitude. First thing I want you to think of when you answer this, where is 0 degrees latitude? Everybody think, don't say anything out loud yet. Where is 0 degrees latitude? Anybody want to answer that? The name of the place is 0 degrees latitude. Whew, thank you. Did you guys all know that? You just were afraid I was going to be a little intense with the answers? Okay, so remember the equator measures how fat the Earth is. So the equator measures how fat, and that's the 0 degrees right there. So the equator is right there. That's 0 degrees latitude. So I'm just going to put an E there. Where's 90 degrees? No, on the Earth, sorry. Where's 90 degrees on the Earth? The name of the place. Guys, this is the stuff you got to know. Where's 90 degrees north? It is the North Pole. Where's 90 degrees south? South Pole. Those are numbers you got to be kind of happy or kind of familiar with. Technically, the equator is labeled on the reference table, but 90 degrees north is not labeled there. Is it labeled? Nope. 90 degrees north is not labeled anywhere. So the equator is labeled, but you got to get happy knowing that 90 degrees is the North Pole or South Pole. See how I'm labeling these guys? I'm not so good with just numbers. When there's a bunch of numbers, I don't do great. But if I have a name on a graph or a label on the graph, I like those. So I would legit, maybe I wouldn't necessarily write them, but I would be thinking, and I'd probably write them to save myself some thinking, because I'll talk about how I don't like to think. If I label them equator and I label it North Pole, then I can talk about intensity of insolation. So when we're at the equator, is insolation intense or weak at the equator? Oh, you guys, I know this. When we're at the equator, is the intensity of the insolation, the incoming solar radiation, it's very intense. The equator is very high intensity. Because the sun, why? Because the sun is high in the sky there. So then when we're at the North Pole, we have high or low intensity near the North Pole. Low, because the sun's low in the sky. So this time the answer is 1. Don't change anything on your paper because I didn't change your paper. But up here, if I change the x-axis to latitude instead of angle of insolation, it completely changed the question. Now, what if I have another package? I'll get those later. Thanks, Mr. D. I'm kind of a slob. Thanks, Mr. D. What if instead of putting latitude, I put, oh, actually, you know what? I'm going to go back to latitude here. So same x-axis as the last one. But what if instead of intensity, I put angle of insolation? So now I changed, I kept that same X as before. Now I changed the Y. Stop and think about this one. Everybody, so by angle, I mean angle of insolation. Everybody figure this one out. If your latitude is 0, which by the way, where is 0 again? The equator. And your then what if we go to latitude of 90? Where's that again? North Pole. Tell me about the angle of insolation. Everybody think first. No one shout anything out. Which one's correct? If we've got latitude on the X. So when we're at the equator, let's do it together. If we're at the equator, is the sun high or low in the sky at the equator? High. So which one of these shows us high in the sky at the equator? First one. And then is it true when we get to 90, is the sun low in the sky? It is. See how I asked 3 basically exact same questions? Had the same pictures. Could have had the same pictures 3 times. What was the only thing I changed? I changed the words on the titles, didn't I? All I changed was the words. What's the #1 rule of earth science? Read all the words. See how if you just skipped or changed one word, you could have got the exact wrong answer? This is what you got to be careful of. And this they're going to try to trick you. And because they trick you, I'm going to try to trick you before they do. So you have to make sure you read all the words. So get comfortable reading and checking the graphs. All right, so back to the original one. So the answer you should have picked on question 1 would have been 3 without changing anything. All right, now the next one. The graph to the right shows air temperatures on a clear summer day from 7 a.m. noon at 2 locations, one in Florida and one in New York State. Air temperature rose slightly faster in Florida than New York State because Florida. You know Florida gets warmer. You guys know that. Do you guys know without looking at the answers why Florida gets warmer? Because it's south of New York. So that's the first thing that comes to my head. Did any answers say because it's south or say anything about that? They don't. So this is another problem where we got to read all the words, including all the answers, to figure out what they mean. So let's read this. Florida has a lower angle of insolation. What does it mean? That's Regent's words. That's fancy earth science vocab. What does that mean for us if we were talking, has a lower angle of insolation? What does that really mean? Low in the sky. Now let's read the next answer. Has a higher angle of insolation. What does that mean? High in the sky. Now let's talk about this next one. Closer to the prime meridian or far away from the prime meridian? Guys, prime meridian. What's the prime meridian? Maybe I get the regular globe out. What's the prime meridian? It's the middle going this way. So remember, we only care about the equator for the sun. It doesn't matter how far or close we are to the prime meridian for the sun. They're trying to mess with you there. What were they trying to hope you got the prime meridian confused with? They were hoping you were thinking equator. And then that would have gone along with what Jake said, further south, closer to the equator. So they were hoping you would pick closer to the prime meridian because they were hoping you got confused the prime meridian and the equator. So then we got to decide, is Florida warmer because the sun is low in the sky or high in the sky? And if we replace those with those words, wouldn't it, you wouldn't even have to think about it, would you? That's what I would do, is replace those words. Take the words that are sciencey and confusing and replace them with what they mean, because you know what it means to have a low angle. We've talked about it enough. That means the sun's low. So write it. When you write it, then you don't have to think about it again. But I also recommend reading all 4 answers too. So sun is high in the sky in Florida. And finally, the average temperature at the Earth's North Pole is colder than the average temperature at the equator because the equator, why is it warmer at the equator? Which one do you guys think? The intense, that high intensity, that strong sun. So if you don't like the word intense, you know what it means. You know what it means. What you all looked at me with a funny look on your face when I said, what's it mean to be intense? Because you know, it means they're being strong, a little aggressive, a little bit in your face. Intense sun, a little strong, a little aggressive, burning your face. So think of it in terms of words you're used to, not science words. All right, so yesterday, let's just catch up to where we were yesterday. We were on page 14. I believe you already wrote the notes. I just didn't really talk about it. Yeah, I think if I remember correctly, we did this yesterday. I had you write this, but I didn't talk about it. So one thing I did say, yeah, so you, Siri wants to get in a conversation. One thing I did say yesterday is the numbers are not what I want you to focus in on here. I want you just to realize what happens to the sun. So we have all the sunlight coming in. 2 things that could happen is, one, it can bounce off the clouds, so reflect, bounce back up into space, or it could get absorbed, sucked into the clouds. Then some of it does make it through the clouds, but then a little bit of it, 8% or so, bounces back off into space when it hits objects on Earth. What are some things on Earth that could cause the sunlight to bounce back up into space? Water's one. Shiny things like metal. What are some other things that could cause the sunlight to bounce back up into space? Mirrors, glass. Don't forget sun, water. No, snow. You already said water. Snow will also cause the sunlight to bounce back up. Okay, technically that's water if you want to be picky about it. And then finally, only a little bit gets absorbed by Earth. Let's talk about that gets absorbed by Earth. So we're going to go on the bottom of page 14. Again, these numbers are not important. I just want you to realize what could happen. But let's talk about when sun, is this the bottom? Yep, right at the bottom of 14. When sun hits the Earth, it can do 2 things. It can either be absorbed, so sucked into, or reflected, bounced back up into space. Here's 2 surfaces it could hit: dark surfaces or light surfaces. Give me some examples of dark surfaces. Rocks. What kind of ground specifically? Hang on, guys, it's my birthday. Participate. Brad, what's a dark surface outside? No, just give me any dark surface. It's not a quiz.
A road.
Road. Roads are dark, especially if they're made out of blacktop, which most of the roads around here are made out of blacktop. Give me some other black or dark surfaces. Now, concrete, let's talk about that. Compared to asphalt, Especially, I can see it right here. Yeah, it says somebody thought it was cool to close my shades yesterday. Was not me. Wasn't me. Ask Gabe. We got blacktop and sidewalk. Hey, how's it feel to be right next to you while I'm showing? We've got blacktop right there and concrete. Would you call the concrete dark when you're comparing them right next to each other? Nah, I wouldn't. No, it's actually not. It's not. Concrete doesn't have a race.
Now you're assuming.
It's my birthday. We're moving on. What happens? You guys have, again, going to use my famous line. You have not lived under a rock. What happens when sunlight hits a dark surface? It gets hot. It heats up. What's the fancy word for that getting hot then? Well, what's the energy do when it hits that dark surface? Absorbs. And then what's it do when it hits a light surface? So if we went out right now and we're able to take a temperature of the concrete versus the blacktop is hotter because the energy is going to reflect or bounce back off of the concrete. Absolutely. Well, it depends on what time of year you want to do it. Like right now, you probably. Oh, okay. Good point. So I'm sorry this is so small. Does anybody need me to read any of it to them? Again, nothing new here. Dark surfaces absorb the heat. The light surfaces reflect the heat. Now, the next thing we're going to talk about is rough versus smooth surfaces. Now, in earth science, of course, the word rough is not typically what you think of, but kind of is. Is sand rough or smooth? Hey, what's sandpaper? Rough or smooth? Oh, okay, George. Way to mess with me. Do you use sandpaper or a piece of cloth to sand anything? Oh, okay, George. You guys are all so confused. Sandpaper is rough. Sandpaper is rough, but you were just thinking, well, a beach is a beach rough? No, but then what happens if you have sand on like your leg and you rub your other leg on it? It is, whoa, fancy word, very abrasive. I think that's a fancy word for rough. I think. You did say abrasive, right? Yeah, which is just a fancy word for rough. Okay, just saying. All right, so sand is rough. Why is sand actually rough? Even though, yes, it's nice to walk on, kind of. It's a bunch of tiny pieces. So those teeny tiny pieces make a lot of surface areas. So rough surfaces, they absorb more. So sand gets so hot. One reason sand gets hot is because of the little pieces that are there. So rough surfaces will absorb more than smooth surfaces. Now, the next part, we've already mastered the next thing. So nothing we're gonna talk about next is new to you. Maybe one new vocab word, I guess. Land versus water. Actually, before I switch it, what heats up faster? Land. As soon as the sun comes out, that sand starts getting hot. The reason for that is what we're going to talk about now. I know I briefly mentioned it last chapter, but now we're going to get really into it. Land heats up faster because water has a higher specific heat. Land cools down faster because water has a higher specific heat. Clearly, we need to talk about specific heat. Write those two bullets and we'll move on to specific heat. If you're done writing, we're going to need your reference table, so maybe grab those. And not maybe, grab those. No, just do it. Changed my words. What? Yeah, I know. I got rid of, I rewound. I said no more maybe, just get them. We're going to keep your packets out though, because we're going right back to the packet. So before we go to the reference table, I think we should learn what specific heat is. So here's the notes for specific heat. We're just about done, guys, so stay with me for a few more minutes. There are two more slides. Well, there's two more slides of notes. No, two. There's a couple. Hey. This is a complicated sounding definition. It's much easier than this definition makes it out to be. So it's the amount of heat. Heat's measured in joules, just like distance is measured in like miles or kilometers. Heat's measured in joules. You don't need to get hung up on that. Joules is just the unit of measure for heat. So it's the amount of heat needed to raise the temperature of 1 gram of substance 1 degree Celsius. That's a fancy way of how much energy is needed to heat something up. That's all. I don't want you to get too worried about exactly, because that does sound super confusing. So we're going to grab your reference table. We're going to go to the front cover. And I think we looked at this already. I'm not sure if your class specifically looked at this. So we're going to be looking at the specific heat chart, which is on the upper right-hand corner. And I want to add a few labels to this. This is just a list of common substances and it says specific heat. So I want to do right here above this, just a little note that says how much energy is needed to heat up an object or a material, I guess. That says how much energy is needed to heat up. I'm gonna go with material. If you haven't already wrote it, it doesn't matter if you did. So how much energy is needed to heat up a material? And if you're not right next to the definition, maybe add an arrow so you know what I'm talking about. And then we just got a bunch of common stuff. We've got liquid water, solid water, water vapor. Yes, they all heat up slightly different. Then dry air, what do you think dry air is? Air with no water. Basalt and granite, those are what? Rocks. So remember how we were talking about land? That's what land's made out of. And then iron, copper, and lead, they're what? Metals. Perfect. So these are just a list of how things heat up. And if it's got a big number, it means it takes a lot of energy to heat it up. So if it takes a lot of energy to heat something up, will it heat up fast or slow? Slow. Let's add that label. Slow, right next to liquid water. And if it takes a teeny tiny bit of energy to heat something up, do you think it'll heat up fast or slow? Fast. So let's add a list or a fast down here to the list. And then everything else, if you notice, the numbers go in order. So the closer to the top, the slower it heats up, the closer to the bottom, the faster it heats up. So, and actually, let's say that here, ESRT page 14. Closer to the, sorry, on, 14. Oh, Cynthia, what are you talking about? ESRT page 1. Gosh, Cynthia. Thanks. Closer to the top. The more energy required to heat it up. And again, if it takes more energy to heat it up, does it heat up fast or slow? So add that, heats up slower. So let's use ESRT page 1, not 14. That'd be dumb. To answer these questions. So have 14. Oh my God, I did it again. Have number 1 next to you. Which material on the chart heats up the fastest? What? Yep, lead. Sorry, I confused myself. Has the smallest specific heat, so it only requires a little bit of energy, so it heats up fast. Which one heats up the slowest? Liquid water, and yeah, you do need to add the liquid part. I know, but on the chart, they've got liquid, solid, and water vapor. So that's why it's important to write the liquid part. So then here's how they ask the same question, but word it differently. Which material needs the most amount of energy to raise its temperature? No, the most amount of energy. So that's the water. It's got the biggest number, so that takes the most energy. All right, now to answer these questions. In each set below, circle the material that would heat up the fastest. So the set means water, iron, or copper. Look at the chart. Water, iron, or copper. Copper heats up faster. Why? According to the chart, why? So Jake, how come copper heats up faster? What about the chart tells me it heats up faster? And that's smaller than everything else. So water has a 4.8 0.18. Iron is 0.45. And copper is 0.38. So the smaller the number, the faster it heats up. How about you guys answer the next few on your own? Ice, basalt, or granite? Circle the one that heats up the fastest. So do those couple right now. Use the chart. We're just looking for the one with the smallest number, requires the less amount of heat, the faster it will heat up. So let's go through this. Ice, basalt, or granite? Granite has a smaller number, so it heats up faster. Lead, water, or iron? Lead. Dry air, lead, or granite? Lead. Iron, basalt, or water vapor? Iron. And ice, copper, or dry air? Copper. All right, let's answer this next question. It says, compare the heating and cooling rate of land versus water using the term specific heat to explain your comparison. Again, on this list, do any of them say land? But which ones imply land? Granite and why? Because they're rocks. Land is made out of rocks. You might want to add that. I just put land in the basalt and granite ones. So let's start this sentence. Land, by the way, land heats up faster because, why does land heat up faster? Check out the land versus the water group. You can keep it even simpler because land has a lower specific heat. And don't pack up quite yet. I want to double check that you know what your homework is. Yep. So, but not all of page 16. So see on page 16, this little area up here, we'll do that tomorrow together. So your homework are just these 4, 5. Why did I say 1 through 4? Hopefully the other class didn't notice that. That's probably the one thing they noticed. I can. So does everybody know what your homework is? The next questions on the next page. All right, guys, have a great night. Was that enough, Brad? Sorry, I moved it. Well, I hope you have a great day and night.